This is Josh Pepper. I will be doing an analog experiment for volcanology. So this is my little baby Bowen's reaction series. We have a gabbro on the left, we have diorite, we have a granite, and then we have this piece of obsidian. So what you're looking at here would be essentially like an intrusive magma. We would have varying degrees of crystal fractionalization. And of course we have this obsidian, which probably wouldn't be in this series or would not be in this series, but for the purposes of this experiment, it'd be nice to have something that we could actually melt. So the theory here is going to be this piece of obsidian is here so we can actually make some actual molten rock and lava. That's going to be essentially just a chunk of silica with maybe some alkali feldspar in it. We have this granite here, and I'm going to try to attack this little pyramid here, and you can see the potassium feldspar, you can see quartz over here, and you can see that lovely little sliver of muscovite. Now my theory is that while the obsidian will probably melt completely, I'll be using a map gas torch which runs at about 2000 degrees Celsius. And some of these minerals may melt and some of them will not, but my hope is that we can get some type of partial melting and actually watch these minerals separate through the process of fractional crystallization. This diorite here is composed of all the typical things. It looks like a typical chunk of diorite. We have plage in there. We have hornblende and biotite. And then we have this nice chunk of gabbro, and you can see the different pyroxenes. This light is really making that olivine pop. Now, something like this olivine is not going to melt until maybe 1500 or 15,000 or 18,000 degrees Celsius. So don't think we're going to get a lot of action at that, but you can see I have all my safety protocol steps in place. I have a recently inspected fire extinguisher. I have my map gas torch burning at about 2000 degrees centigrade, my safety goggles, my gloves, my lab coat. All right, let's make lava. Yes, and you can see the reaction kind of taking place. Just a little bit there, you can see those edges are softening up, and we're actually going. You can start to see some plasticity. Yeah. Working quite nicely. So, though we don't quite have the temperatures needed to make this happen, in theory you would see that silica separate through some of those alkali feldspar. And you can see those edges rounding, and you can tell we're headed in the right direction. Oh yeah. We are making lava, baby. Alright, we're going to attack this chunk of granite here for a second and see if we can, if I can position it there so you can see this. I'm really going to try to focus on that muscovite. And you can see that glowing there and becoming molten red hot. I'm going to keep this flame on here a little longer. And if I'm going to get any results at all, it will be from this sample. Fortunately, it looks like it's going to be slightly uneventful because I just don't have the temperatures I need to get this reaction to start. As you can see, it's getting molten hot. It's actually turning red. Sunlight's not the best friend right now. Alright, well at this point we're basically going to switch gears here and see if I can get my obsidian to melt, so at least we have some type of results to look at. We weren't able to achieve high enough temperatures to get that granite to melt. You can see my muscovite is basically untouched. I'm going to pick it up here in a second and give you a closer look, but we saw absolutely no degrees of partial melting, and so of course we weren't able to observe any crystal fractionation, so let's see if we can melt some rocks though and at least have something fun to look at. So I'm competing against a little bit of wind here. Quartz will melt at 800 degrees Celsius, and you can see we are getting some results here. We're making magma, baby. Alright, well, while this experiment was not a complete success, it was not a complete failure either. So, we did actually make ourselves some molten rock here. And you can see this piece of obsidian actually changed shape there and it melted. Got a little bit more shiny. Now this chunk of granite, I'm going to go ahead and pick it up with my leather gloves here and see if we can look at what happened. You can see that little flake of muscovite essentially unaltered. I got no separation of my potassium feldspar or quartz. So again, this is Josh Pepper, volcanology analog experiment. Basically, we learned we need more heat to make lava. Thank you.